डियर स्टूडेंट, आज हम लोग डिस्कस करेंगे सम इलेक्ट्रॉन डिस्प्लेसमेंट इफेक्ट्स इन कोवैलेंट bonds. Means in a covalent bonds electron get displaced. Now what are the different effects which displace the electrons in a covalent bond? So कौन सा इफेक्ट होगा जो इलेक्ट्रॉन को डिस्प्लेस करते हैं? वो है पहला इंडक्टिव इफेक्ट और आई इफेक्ट, इलेक्ट्रोमेट्रिक इफेक्ट और ई इफेक्ट, रेजोनेंस इफेक्ट, आर इफेक्ट और इसको मेसोमेरिक इफेक्ट और एम इफेक्ट एंड हाइपर कंजुगेशन. These are electron displacement effect. They displace electron in the covalent bond. So let us understand one by one. So पहला हम लोग डिस्कस करेंगे पहला इंडक्टिव इफेक्ट. Suppose there is a covalent bond between hydrogen and hydrogen. So this is a covalent bond. This is a sigma covalent bond. You know there are two types of covalent bond. One is sigma covalent bond, another is pi covalent bond. So see here, these two hydrogen atoms, they are the same atom. They have the same electronegativity. Now what is electronegativity? It is the power to attract shared paired electron towards itself. I repeat, it is the power of an atom to attract bond pair electron, shared paired electron towards itself. So here the same atom, same power. So जो shared paired electron, bond pair electron, they lie exactly middle of the two atom. क्या होगा यहाँ पे? दोनों इलेक्ट्रॉन सिग्मा इलेक्ट्रॉन और शेड पेड इलेक्ट्रॉन, बॉन्ड पेड इलेक्ट्रॉन एग्जैक्टली मिडिल में रहेगा. क्यों रहेगा? बिकॉज सेम इलेक्ट्रोनेगेटिविटी. नाउ इफ हाइड्रोजन इज covalently bonded with a fluorine atom, so you know fluorine atom is highest electronegative element. अभी क्या होगा? अभी जो बॉन्ड पेड इलेक्ट्रॉन ये एग्जैक्टली मिडिल में नहीं रहेगा. कहां पे चलाया जाएगा? टुवर्ड्स फ्लोरीन एटम चला जाएगा. बिकॉज फ्लोरीन इज द मोर इलेक्ट्रोनेगेटिव, मींस इट हैज अ हाई पावर टू अट्रैक्ट पेयर ऑफ इलेक्ट्रॉन. सो दिस electron displaced towards the more electronegativity. This is a displacement effect. Electron displaced towards the more electronegative atom. As a result, this fluorine atom acquires a partial negative charge. This hydrogen atom acquires partial positive charge. That means now this covalent bond become polar. So this is a polar covalent bond. Polar covalent bond. And this is non-polar. This is non-polar. So you have understood the how polarity creates in a covalent bond because of the electronegativity difference. Now same situation, same concept if we apply in organic chemistry. Suppose our carbon atom, organic chemistry dealing with carbon atom or carbon chemistry, attached covalently bonded with a highly electronegative atom such as chlorine. Suppose a carbon chain, so this is a carbon chain, this is the carbon chain attached with a highly electronegative element say chlorine atom. What will happen now? See same situation occur here also. यहाँ पे क्या होगा? देखो यहाँ पे जो सिग्मा इलेक्ट्रॉन एग्जैक्टली मिडिल में तो नहीं रहेगा, कहाँ पे? इट इज शिफ्टेड टुवर्ड्स द मोर इलेक्ट्रोनेगेटिव हो जाएगा. सो इट विल एक्वायर्स पार्शियल नेगेटिव चार्ज, it will acquire partial positive charge. Now this bond become polar covalent bond. Now because of this polar covalent bond, यहाँ पे इन दिस सिचुएशन से हियर यहाँ पे भी ये दोनों इलेक्ट्रॉन एग्जैक्टली मिडिल में नहीं रहेगा, ये भी इलेक्ट्रॉन टू शिफ्टेड टुवर्ड्स द क्लोरीन एटम हो जाएगा, ये भी यहाँ पे आ जाएगा। सो यहाँ पे डेल प्लस क्रिएट होगा, यहाँ पे स्टिल पॉजिटिव चार्ज क्रिएट होगा, वो भी लेस देन इससे होगा। सो इसका हम लोग लिखेंगे डबल डेल प्लस, यहाँ पे भी पोलैरिटी क्रिएट होगा, यहाँ पे भी ट्रिपल डेल प्लस। सी बिकॉज ऑफ पोलर कोवलेंट बॉन्ड, because of electronegativity difference, because of polar covalent bond, polarity induces in a adjacent bonds. So this effect is called inductive effect. Now this inductive effect is permanent. Why permanent? Because this polarization is a permanent polarization. Because of this polarization, here polarity induces, here polarity induces. Polarity induces means there is a displacement of electron. The displacements of electron takes place because of the polarity of a covalent bond is known as inductive effect. I repeat, displacement of sigma electron, displacement of sigma electron in a carbon chain due to the polar covalent bond, displacement of sigma electron due to the presence of polar covalent bond, due to the presence of electronegativity is known as inductive effect. I think you have understood this. Now, inductive effect or I effect, there are two types of inductive effect. Means, number one, types of inductive effect. Types of I effect. Number one, plus I effect, and number two, minus I effect. Now you see, what is plus I effect? Let us first understand minus I effect. In this case here, this is the chlorine atom. Also, this is called substituent. The substituent क्या कर रहा है यहाँ पे? ये substituent क्या कर रहा है? ये इलेक्ट्रॉन क्या कर रहा है? अपनी तरफ उड्र कर रहा है, माने इलेक्ट्रॉन अट्रैक्टिंग टुवर्ड्स इटसेल्फ. So withdraw from the carbon chain, attract electron from the carbon chain. तो यह क्या, इसको कहेंगे हम लोग नेगेटिव इंडक्टिव इफेक्ट. देखो ये जो कार्बन, बिकॉज ऑर्गेनिक केमिस्ट्री डीलिंग विथ कार्बन केमिस्ट्री, यहाँ पे जो दिस कार्बन इज आवर वेरी इंपॉर्टेंट कार्बन, जो बिकॉज जो होगा यहाँ पे होगा इस कार्बन में होगा, क्यों? बिकॉज दिस कार्बन इज अ हाईली पोलर कोवलेंट बॉन्ड. जो यहाँ पे जो ब्रेकिंग, यहाँ पे ब्रेकिंग क्विकली ब्रेकिंग होगा बिकॉज हाईली ये पोलर कोवलेंट बॉन्ड. सो ये कार्बन इज वेरी इंपॉर्टेंट कार्बन यहाँ पे. सो यहाँ से इलेक्ट्रॉन उड्रो कर रहा है, ये ग्रुप क्या इलेक्ट्रॉन उड्रो कर रहा है, तो इलेक्ट्रॉन अपने तरफ. सो ये नेगेटिव हुआ ना, कार्बन से इलेक्ट्रॉन चला गया, सो इट्स नेगेटिव. अगर कार्बन गेटिंग इलेक्ट्रॉन, ये कार्बन अगर गेटिंग इलेक्ट्रॉन तो पॉजिटिव. उड्रो, ये क्या इलेक्ट्रॉन उड्रो, ये ग्रुप क्या हो गया इलेक्ट्रॉन उड्रोइंग ग्रुप, तो दिस इफेक्ट इज कॉल्ड माइनस. तो एनी सब्स्टिट्यूएंट or atoms or groups, also substituents, withdraws electron from the carbon chain are called minus I affecting group, and this effect is called minus I effect. So minus I effect क्या कहेंगे इसमें से suppose so here here this chlorine atom would draw electrons, so it is a minus. Here is a effect is minus I effect. So some groups are say, for examples, our NO2 group, shows mine NO2 group is most powerful than that of say our CN group, say our carboxylic group, fluorine, chlorine, bromine, iodine, say hydroxide. So these are all minus I affecting group. They withdraw electron from the carbon chain. Now, any substituent who donates electron to the carbon chain, I repeat, any substituent donates electron to the carbon chain are called plus I affecting group, and the phenomenon is called plus I effect. For example, the CH3, CH3, CH2, Cl. See, this is the group. This is the group has a ability to donate electron. इसको CH3 के CH3 ग्रुप क्या करते हैं, हमेशा इलेक्ट्रॉन डोनेट करते हैं. यहाँ पे जो, तो यहाँ पे हम लोग एक क्या होगा, यहाँ पे प्लस आई इफेक्ट. देखो यहाँ पे शो कर रहा है, यहाँ पे क्या हो माइनस आई इफेक्ट, यहाँ पे प्लस आई इफेक्ट. सो आई इफेक्ट ऑलवेज डिनोटेड बाय एन एरो एट द मिडल ऑफ द बॉन्ड. So any atom or group of atom who donates electrons are plus I affecting group, and the phenomenon is called plus I effect. So generally all alkyl groups are plus I affecting group. So all alkyl group, say CH3 thrice C, say one of the group, say one of the group is most power than CH3 twice CH, CH3, CH2, then CH3. So these are this is alkyl group, alkyl group, this is alkyl group, this is also alkyl groups. So this tertiary alkyl group is most powerful plus I affecting group. The methyl group, ethyl group, isopropyl, tertiary butyl. So these are the plus I affecting group. These are the minus I affecting. Second is electrometric effect. Electrometric effect or E effect. Electrometric effect or E effect. What is the definition? The temporary polarization occurs in a molecule containing multiple bonds under the influence of attacking reagent is known as electrometric effect. I repeat the definition. It is the temporary polarization occurs in a molecule containing multiple bonds under the influence of attacking reagent is known as electrometric effect. So let us understand the effect. Suppose there is a C double bond C. So this is a carbon atom containing multiple bond. Here one bond is sigma, another bond is pi. Sigma bond, another is pi bond. Now, okay, sigma bond and pi bond. We have understood the attacking, we know the attacking reagents. Attacking reagents are electrophiles and nucleophiles. They are denoted as electrophiles. Electrophiles are E plus and nucleophiles NU minus. The electrophiles, these are nucleophiles. So in under the influence of attacking reagent, there is a temporary polarization occurs in a molecule containing multiple bond. One is sigma bond, another is pi bond. Now see what happened. Suppose electrophile is coming. Electrophile, there is a electrophile E plus. What happened? This pi electron, under the influence of this pi electron shifting towards this carbon atom and become a lone pair of electron. Become a lone pair. This only occurs under the influence of attacking reagent. Now this lone pair electron invites the attacking reagent. but चलो मेरे साथ एक बॉन्ड फॉर्म कर लो. तो क्या हो गया, देखो क्या हो गया. See here. This pi bond shifting away from this carbon atom. Remember this carbon atom, C, and this lone pair forming a bond with electrophile. Say this is our electrophile, and earlier two bonds are already there, two bonds there. So this carbon atom, 1, 2, 3, 4 satisfied. Now see this lone pair shifted. See, this is become a positive. Now see the displacement of pi electron takes place. Displacement of electron takes place under the influence of attacking reagents. Now see here, there is a polarization occurs in the molecule because of the attacking reagents. Now this effect is a temporary. As soon as you remove this electrophile, the molecule revert to its original structure. Okay, that's why it is temporary. Under the influence, there is a displacement of electron. Under the influence of attacking reagent, there is displacement of electron. If no attacking reagents, there is no displacement of electron. But in case inductive effect, it's a permanent because electronegativity is there. So this is a basic difference. I repeat, there is attacking reagent, there is displacement of pi electron. No attacking reagent, no displacement. That's why it's a temporary. Now similar again, if we same situation, this is due to electrophile. Now let us understand with the help of a nucleophile. Same example, same nucleophile. Now the nucleophile when approaches this pi system, this molecule containing multiple bond, क्या होगा, ये जो इलेक्ट्रॉन सपोज ये इसको अटैक करेगा. This pi electron have to shift to the other carbon atom. Have to shift. So what will happen? See, there is a nucleophile bond between carbon and nucleophile, and lone pair. There is an electron. So this is the situation will occur. So they again here see displacement of electron, pi electron under the influence of an attacking reagent, displacement of electron under influence of attacking reagent. So polarity occurs in a molecule due to the presence of attacking reagents. So these are electrometric effect. Now electrometric effect again two types of electrometric effects. Say E effect. So number 1 plus E effect, and number 2 minus E effect. See here, when displacement, that is electron, when there is a displacement of electron, from the attacking region to the carbon chain, it is called negative electromagnetic effect. So what will you here see? What will happen? There is a displacement of electron from the carbon chain to the attacking region. When displacement of electron towards the attacking region, I repeat, when displacement of electron towards the attacking region, it is regarded as a positive effect. When displacement of electron away from the attacking region, it is called negative inductive effect. Sorry, negative electromagnetic effect. So it is negative electromagnetic effect. It is our positive electromagnetic effect. I repeat, when displacement of electrons takes place towards the attacking region, it is plus E. When displacement of electron away from the attacking region, it is called minus E. So you can remember in other way by see the charge of electrophile. If the attacking region is electrophile, say positive, electrophile is positive. If the attacking region is positive, plus E effect. If the attacking region is negative, minus I effect. In this way you can understand. I repeat, just to understand this, if the attacking region is positive, when positive electrophile, plus E effect. If the attacking reagent negative, nucleophile, negative, minus E effect. So I think you have understood inductive effect and electromagnetic effect. So basic differences between electromagnetic effect and inductive effect is, say, inductive effect is permanent, electromagnetic effect is temporary. Inductive effect involves the sigma electron, but electromagnetic effect involves pi electron. Inductive effect, no attacking reagent required, but electromagnetic effect attacking reagents is required. So these are some basic differences between electromagnetic effect and inductive effects. So thank you for watching this video.